so we are dividing polynomials by long division today. All we're doing is like doing a procedure. Tomorrow we'll use it to find stuff. But today it's just a procedure. And it's totally review from Algebra 2. And long division you should have learned for the first time maybe 4th or 5th grade. So long division, let's see, where do we start? We go one of those guys and we put x squared plus 3x minus 10 underneath it. Outside we put x minus 2. Right? All right, then we're going to divide the first term into the first term. And I have some people who have trouble with this. So how many times does x go into x squared? No. So if you have trouble with it, you can think x squared divided by x. What's x squared divided by x? It's x times. I know you want to say twice, but that's not.
I mean, I would have put that either way.
You would have put x even though you said twice?
Yeah.
Oh, okay. So then we multiply, and we multiply x times x, which is x squared, and we multiply x times minus 2, which is minus 2x. So we're distributing this x back into our divisor. After that, we're going to draw a line and we're going to subtract. But I personally have seen many mistakes when we do subtraction. So I like to say draw the line, change all the signs, and add instead. So instead of subtracting, we are adding the opposite. So we draw the line, change all the signs. Then you can add them. Add them. If you have found the correct number on top, or x in this case, then the first terms should cancel out completely. And then we get 3x plus 2x is 5x. And after that, you bring down the next term. Now we do the procedure a second time. So we take x and we divide it into 5x this time. So if you're not sure how to do that by hand, just do it off to the side. 5x divided by x is what number?
5.
So up top, we're not going to write 5, we're actually going to write plus 5. And now I'm going to distribute 5 to the x and 5 to the minus 2. So we get 5x minus 10. Then I'm going to draw the line, and I'm going to change all the signs so I can add them. And when I add them, what do I get? 0. The reason why we got 0, there's no remainder, because x minus 2 divides evenly into x squared plus 3x minus 10. So you would say that x minus 2 is a factor of x squared plus 3x minus 10. The final answer is x plus 5. So x minus 2 times x plus 5 is x squared plus 3x minus 10. Okay, so the next one, we're going to do long division again. 3x plus 2 divided into 9x to the 4th. Who remembers what's special about this one? You have to have a placeholder. So it can't skip and go to x squared. You have to have every single descending power. So because I skipped it, we have to put in 0x cubed plus 14x squared plus 0x minus 8. So if there is a missing power in descending order, you've got to put it in. That just made this problem way longer. So we divide. We're dividing 3x into 9x to the 4th. If you don't know what that is, go off to the side and say 9x to the 4th divided by 3x. What do I get? 3x to the 3rd. Then you distribute 9x to the 4th plus 6x to the 3rd. And we draw the line, and we change our signs so we can add them. And then we bring down 14x squared. Have you done this before? Angelia, have you done this before? So now we take 3x into negative 6x cubed. If you don't know what that is, go off to the side. Negative 6x cubed divided by 3x gives me what? Negative 2x squared. We distribute it. We got negative 6x cubed minus 4x squared. Draw the line, change the signs. Okay. Now we're going to add it. No. You guys don't think this is the most exciting thing ever? And then we bring down 0x. Seems silly that we're bringing down 0, but it really is helpful to have that placeholder. Okay, then we divide again. 3x goes into 18x squared, and that happens 6x times. Then we distribute 18x squared plus 12x. Now what do? Draw the line, change the sign, so we can add them. Negative 12x. Now what do? Bring down minus 8. How do I know when to stop bringing stuff down?
There's nothing left to bring down.
Exactly. 3x goes into negative 12x minus 4 times. Distribute. Negative 12x minus 8. Draw the line. Change the signs. Add them together. I get 0. So, is 3x plus 2 a factor of that big long polynomial? Yes, it is a factor because it has a no remainder when I divide it. My quotient is 3x cubed minus 2x squared plus 6x minus 4. All right, one more long division, and then we'll do synthetic. You don't want to do synthetic?
I don't know what that means.
Isn't synthetic easy?
That's the real easy one, yeah. The problem is synthetic doesn't always work. So long division always works. Synthetic works in certain situations. So if we can use synthetic, we will, but you can't count on it. All right, so we're going to divide this, but I got to put in placeholders. So I'm going to have x squared plus 0x minus 1 on the outside. So you can put placeholders over there too. And then x cubed plus 9x squared plus 0x minus 5. So if you didn't put the placeholder there, that doesn't mean you're going to get it wrong, but it makes it a lot more confusing.
Why would we do it?
What?
Oh, no.
Why do we do it?
No, I understand that one.
Now, when you go to do synthetic division, if you don't put the placeholder in, you will get it wrong. So it's just a good habit to have. All right, so we're going to divide. You guys tell me the answer. How many times does x squared go into x cubed? X, right. So I should be able to multiply x times x squared and get x cubed, which I did. X times 0x and get 0x squared. And x times minus 1 and get minus 1x. So I had to distribute it to 3 terms. You draw the line, change the signs. Add them together. 9x squared plus x, bring down minus 5.
So you just bring down, like, if you had 9x squared plus x, you just bring down one more thing.
Yes. Yeah, so what you want to have dividing into is how many we have out here. So now I'm going to do it again. X squared goes into 9x squared. How many times? 9. And we distribute, we get 9x squared plus 0x minus 9. Draw the line, change those signs. Add them together. I get x plus 4 as my remainder. So how do we write the remainder?
R dot dot.
I don't know what you just said. I don't know what you just said. But I'm thinking it's not what I'm about to write. X plus 9 plus x plus 4 over x squared minus 1. You put the remainder over the divisor and you add it onto what you're dividing, or what your quotient is. So it'd be like the end. That would be like if I took 7 and divided it by 2, that would go in 3 full times with a remainder of 1 over 2. Like that's the equivalent of what we just did there. Only it's way more complicated than okay? So is x squared minus 1 a factor of x cubed plus 9x squared minus 5?
No.
It is not a factor because there's a remainder. You don't have to say that in your homework. I'm just going over it because it's going to help us do things with it later. All right, synthetic division. Ready? Okay, so synthetic division only works if we have 1x to the first power in our divisor. So if you have any other number in front of that x, or if you have any other power, you cannot use synthetic division. So it only works 1x to the first power. Otherwise, you have to use long division. That's why we have to learn both. Other than that, though, synthetic division is way faster. You may have written the lines or the boxes slightly different. It's okay. There's different variations of writing this. It's all the same work. We're going to take the divisor. You're going to set it equal to 0 and find a number. That would be 3. That's the number we're using kind of off to the side in our box or outside of the line, depending on how you write it. Then, in line with that, we're going to write all the coefficients with placeholders, if needed, of the numerator. So 1, negative 11, then 0, then 6. And we leave a space, and we draw a line, and we start our synthetic division. Remember?
Yeah, a little bit.
Yeah. So we're going to bring down the 1 always, whatever's first. It's not always a 1. So you bring down the first number. Then we multiply 1 times 3 and put it under negative 11. And then we add them, negative 8. Then we multiply negative 8 times 3, we put it under 0, and we add them, negative 24. We multiply negative 24 times 3, we put it under 6, and we add it, negative 66.
What am I adding?
The two numbers in the page.
What did I start with?
First step is bring down the 1.
Oh, I got you.
Okay, once you get there, this last number is always the remainder. Bless you. The last number is always the remainder. That's why I just put it in a box, because that's my remainder. Okay? And because we divided by 1x to the first power, that will always make our answer 1 power less than the original. It will always be 1 power less than whatever that is. So my answer is going to start with an x squared, and this is the coefficient. So we're going to have 1x squared minus, then we go in descending powers of x, 8x minus 24. And since it's a minus 66 as a remainder, I write minus 66 over x minus 3, my divisor. Okay.
Is it like wrong to say like you would know that negative 24 is like about an x and then x?
You can go backwards. I feel like I see more mistakes going that way.
Is there a reason why?
When we have zeros in here, people miss things. Because sometimes you'll have like zeros in these spots, like literally 0, right? If you understand, since we're dividing by 1x, that it's going to be 1 less. Either way is fine. Mm-hmm. Okay. So the next one, we'll start out by putting that number outside the box. What number is that going to be? Negative 2. Then we write our coefficients. 2, 5, 5, 6. Leave some space, draw a line. Then what do we do first? Drop down that first number 2. Then you start multiplying and adding. Multiply 2 times -2. -4. Add the 5. 1. Multiply. -2. Add the 5. 30. Multiply. -6. Add the 6. 0.
Why don't you draw a box over there? Why don't you draw a box over there?
I always draw a box on my remainder. You don't have to. I always draw a box on my remainder. So my answer is going to be 1 less exponent than the original degree. So my answer is going to have x squared. So we're going to start with 2x squared plus 1x plus 3, and then there's no remainder. So you can say that x plus 2 is a factor of 2x cubed plus 5x squared plus 5x plus 6. Because there's no remainder, it is a factor. All right, next one. What goes in the little box? Positive 2. Then we do 2. Then we do 0. Then we do -3. Then 0. -10. 7. So you have to have those placeholders, otherwise you will get it wrong. Bring down the 2, multiply, add, 20, 20, 27. So 27 is my remainder. I know x minus 2 is not a factor. My answer is going to have 1 less exponent, so it's going to be 2x to the 4th. 4x cubed plus 5x squared plus 10x plus 10, I've run out of space, plus 27 over x minus 2.
Doug did have it.
Okay, last section is finding the value of a function at a given number. So find g of 2. How would you do that? You'd plug it in, but I'm going to show you a different way. So we do know you could just plug in 2 to the 6 minus 4 times 2 to the 4th plus 3 times 2 squared plus 2. And if you don't have a calculator, have fun. Okay? But we can also do this by synthetic division. So to do it by synthetic division, you make that number you're plugging in the number that goes in the box. 2. And we write our coefficients. So 1, and then 5th is missing, 0. The 4th is -4. The 3rd is missing 0. Squared is 3. To the first power, 0, and then 2. And then we do synthetic division. 1 multiplied by 2, add it. Multiply by 2, add it. Multiply, multiply, add. Multiply, add. Multiply. So you should be actually doing the synthetic division, not just copying my numbers down. You should be doing the synthetic division and seeing how fast it goes if you know your multiplication and addition skills. Now, on your calculator, please type in the value of 2 in this equation to see what we get. We just did it by synthetic division, but I want you to see on your calculator what you get when you plug in 2. And then don't yell it out. I want you to try it by yourself on your calculator. Don't yell it out. Just try it on your calculator. Why aren't you doing this one on the calculator like I just asked?
I have nothing else.
Okay, good. Just type in 2, like, you see how I wrote it above there, 2 plus 6 minus 4. Type it in the whole way. Who has it typed in their calculator in one line and has a color calculator so it'll look brighter? The darker ones will show up there. It's got to have a color one. I know. If I have it in the color calculator, it's a whole lot of colors. Oh, finish. you finish it before somebody else does, I figures. Do you have it? Okay, so you see, you have your synthetic division, and you look at that compared to your answer by plugging it in. The answer is 4. Oh, come on. Let's just, fine. She said it's good. Okay, so the answer is 14. Where did we get that from the synthetic division? It's the remainder. That's called like the remainder theorem or something like that. But if you want to find the value at the function when g is 2 and you do synthetic division, it's the remainder every time. Okay, so I want you to try do g of -4. It is the exact same function, so you can use the same top line except for -4. Go ahead and try to do that one. And then you can check it on here, but I want you to try to do it using synthetic division. Yeah, you have. And I would love.
So, this is the answer.
Yeah, that is the answer. G of 2 is 14.
So the other numbers mean anything?
Not for this particular, not for the directions it's asking. You would just need the remainder. So we're doing -4. Okay, so I don't need double page anymore. I hear a lot of calculating. Why is that? I know. So I start doing this by hand, and I get to -48, and then I'm like, okay, so I'm gonna have to use my calculator after all. So sometimes doing synthetic division isn't always the fastest way. Sometimes, I mean, you could still do this by hand. You just have to multiply it. 192. And then 195 times -4 is -780, right?
Yep.
Because I've done this a few times already. And you multiply those and you get 3120, and you add them, you get 3122. That's your answer. So using that, you can kind of check your synthetic division for any of them above also. You can go back and check it. That's all we have for today, synthetic division and long division. I have a worksheet for you. And if you are still working on any of the worksheet that was due today, you can work on that. The rest of class, you can work on this one the rest of class. Ask questions.